First introduced in 1702 by a French physicist. What is the absolute zero? How cold is it? Can we ever reach this state? And what's happened when we reach it? Let's discover more about it. Absolute zero is a major statement of thermodynamics. It is the lowest theoretical limit at which the enthalpy and entropy of an ideal gas reach their minimum value. The definition proposed in 1868 by Lord Kelvin is perhaps less obscure. He defines absolute zero as the temperature at which no more heat can be extracted from a substance. He also proposed a temperature scale called Kelvin, with its 0 point sets at absolute zero. By international agreement, the absolute zero's value is minus 273.15 Celsius and has been extrapolated from the ideal gas law. The laws of thermodynamics imply that absolute zero cannot be reached by purely thermodynamic means. Indeed, the temperature of the cooled substance approaches asymptotically that of the cooling agent. Nevertheless, scientists have succeeded in reaching temperatures close to absolute zero, where matter, nearly in its minimal energy state, exhibited quantum effects such as superconductivity or superfluidity. Superconductivity is observed in material where electrical resistance vanishes. Superfluidity is a property of a fluid with zero viscosity which therefore flows without any loss of kinetic energy. The current lowest temperature world record was set in 2021 at 38 picokelvin. As a comparison, the average temperature of the universe is approximately 2.73 kelvins. The race to reach this very low temperature started in 1845, when Michael Faraday managed to reach 143 kelvins, about minus 130 Celsius degrees, developing a protocol using solid carbon dioxide and low-pressure ether. But this temperature is not cold enough to condense gas like oxygen or hydrogen, and Faraday finally thought it was not possible to condense them. But in 1873, Dutch physicist Johannes van der Waals demonstrated that is possible, but at much lower temperature. And in 1898, James Dewar was the first to liquefy hydrogen and reach the temperature of 23 kelvins. Finally, 10 years later, Kamerlingh Onnes was the first to liquefy helium, reaching the amazing temperature of 1.5 Kelvin. The race to ultra-low temperature is not finished, and some scientists expect to achieve temperatures as low as 1 picokelvin. This will further the exploration of unknown quantum mechanical phenomena and test some of the most fundamental laws of physics.